Good morning class 9th. Today we are going to discuss the chapter Factorization. Now what is Factorization? In junior classes you've learned to find HCF and LCM with the help of, you used to call them prime factors or factors method. Like for example, if I take a number 24. If I take a number 24 and I want to find the factors of 24, what does it mean? You know 1 is a factor of everything, so I'm not going to write 1. But 2 will divide 24 completely. Number 3 will divide 24 completely. 4 will divide number 24 completely. 6, 8, 12, and of course 24 will divide. So all these numbers 2, 3, 4, 6, 8, 12 are factors, I can write it as 2 and 12. So 2 and 12 will become factors, meaning that if I divide 24 by 2, I'll get the quotient as 12. Or if I divide the 24 number by 12, I'll get the quotient as 2. 3 into 8. If I divide 24 by 3, I'll get the quotient as 8. Or if I divide it by 8, I'll get the quotient 3. Remainder in each case will be 0. For example, if I take 4 into 6. So if I divide 24 by 4, I'll get the quotient as 6. Or if I divide it by 24 by 6, I'll get the quotient as 4. Remainder in each case is 0. If remainder is coming, then it cannot be a factor. Remember that. Suppose I take number 7. Now, if I can divide 24 by 7, 7 3s are 21, but remainder 3 will be left. So 7 is not a factor of 24. 7 is not a factor of 24. Any number which cannot divide the given number completely is not a factor. This is just to give you a basic idea. Actually, factorization is a reverse process of multiplication. It's just the reverse process of multiplication. Now we are going to apply it to algebra. And how are we going to do it? In algebra we have factorization. And generally a question is asked by students to a teacher that how do we know that there are different methods of factorization, so which method will be applicable to the questions which I have written here. We are dealing with one kind of factorization just now in this lecture. I am only taking the questions where I have to take out the common factor. The first thing which you look into whenever you are asked to factorize, that can you take out something common out of the given terms. For example, let us deal with question number 1, which says 8xy to the power 3 plus 12x square y square. Now he says factorize this. Factorize this. So out of 8 and 12, what is common? What is common? 8 has got factors. I mean, the highest common factor will be 4. 4 2s are 8, 4 3s are 12. So I will take 4 as a common out of 8 and 12. Out of x and x square, I cannot take x square common. I'll take only x common. Out of y cube and y square, I'll take y to the power 2 common. So what will be left inside? 4 2s are 8. X has gone out here. Y square has been taken out, so y. Plus 4 3s are 12. X has gone out of x square, so x is left, and that is it. So your answer would be 4xy square 2y plus 3x. You must leave the answer in the simplest form. Meaning thereby, if I divide this expression 8xy cube plus 12x square y square by this expression 2y plus 3x, I'll get the quotient as 4xy squared. Or if I divide it by 4, I'll get xy squared into 2y plus 3x. Or if I divide it by 4xy squared, then I'll get 2y plus 3x. So these are the factors of this expression. If you have difficulty in understanding, then what we do is whatever you've taken out common, you divide every term by that common, whatever you've taken out common. For example, I've taken out 4xy square common, so what I can do is 8xy cube upon 4xy square plus 12x square y square upon 4xy square. I am dividing each term individually, whatever I have taken out common. So what will I get? Here 2, 4 2s are 8, x will cancel, y will remain, plus 4 3s are 12, x square will, we have taken y square common, 4 y square will cancel, and x and x. And because we had divided it by 4xy square, so it will come here. So you get the factors as 4xy square into 2y plus 3x. Whenever you are asked to factorize, the first thing what you should look is that is it possible to take out something common? First thing we are going to look into that, and then we can go beyond that. For example, let us see question number 2. It is 4x to the power 3 minus 6x to the power 2. Now we know 4 and 6 are multiples of 2, so I can take out definitely, these are even numbers. Even numbers are the numbers which are exactly divisible by 2. So out of 4 and 6 I can take 2 common because that is the highest common factor. So I take out 2 common. Out of x cube and x square, the variable with the lower power is taken out common. For example, it is x cube, it is x square. The lower power is 2. So we can take that out common. X to the power 2. What will be left? If I divide it by 2, it will be 2x and minus 3. So there are factors 2x square into 2x minus 3. And if we divide by any of these, we will get the other portion as the quotient. When the 4 and 6 are constant, x cube and x square are called variable. X is a variable. Let's see the third question. 2 pi r square minus 4 pi r. Again 2 and 4 are even numbers. I can take 2 common. Pi is again a constant. You have used pi earlier also in physics as well as in mathematics. Pi is common. Out of r square and r, we have r common. So it will be r minus 2. So I have two factors, 2 pi r into r minus 2. We factorize till we must get the simplest form, meaning that if something else was there and we could take out common or factorize, we should have done that. But there is nothing out of r minus 2 which I can take out common. So this is your final answer. Let me see the fourth question. I have 28 p squared q squared r minus 42 p q squared and r squared. Now 28 and 42. Now both comes in the table of 14. 14 2s are 28, 14 3s are 42. That is why tables are also important. We keep insisting the importance of table. We are using calculators, but tables are required. For faster calculation, it is better that you know. Out of 28 and 42, I can take 14 common, which is actually 14 2s are 28, 14 3s are 42. Out of p square and p, I'll take p common. Out of q square and q square can be taken out common. Out of r and r square, r is common. Now what will be left here? 2. P has gone from here, so only 1p will be left. Q square has already gone, r has already gone, so you are left with 2p. Minus 14 3s are 42. P has gone here, Q square has gone here. Out of r square, r has gone, so 2p minus 3r. These are your answers. So you have these factors. Let us see the fifth question. In the fifth question I have 8x cubed minus 6x squared plus 10x. Now instead of 2 terms I am having 3 terms. So what is the problem? There is no problem. You just look what is possible to take out common in these 3 terms which are given. Out of 8, 6 and 10, of course they are all even multiples. I can take only 2 common. I can take only 2 common. 2 is the highest common factors of 8, 6 and 10. Then out of x cube, x square and x, I can take x common. So x is common. Now you divide 8x cube by 2x as I told you in the beginning. 2 4s are 8 and x square, or I say 8, 2 has gone, 2 4s are 8. X cube, out of x cube, x has gone, 1 power has gone, so 2 power are left. 3s are 6, x plus 5. So these are the factors of this. Now let us look into the 6th question, which is 27 a cube b cube minus 18 a square b cube plus 75 a to the power 3 b to the power 2. Now let us see what can we take common out of all these 3 variables or terms which are given here. Out of 27, 18, 75, what can we take? Because if you start multiplying, you say, okay, out of 27 and 18, 9 is common. 9 3s are 27, 9 2s are 18, but what about 75? 75 can't be divided by 9, so I cannot take 9 common. So again, I am going to look for a number which will be dividing each and every number. That is only meaning that I can take common. 27, 18, 75, 3 is the only number which is common. Out of 27, 18, 75, 3 is the number which is common. Out of a cube, a square, a cube, I can take a to the power 2. I said when we are talking of variable, then take the variable with the lower power. Out of b cube, b square, again b square is common. So when I take out this common, 3 9s are 27, a will be left here and b will be left here. A cube, out of a cube I have taken out a square, b square I have taken. Then 3 6 18, a square is gone, b square is gone, so b will be left. Plus 15, 25. 3 2s are 6, 3 5s are 15, 25 times. Out of a cube, a square is gone, so a will be left. 25a. Now when I said that we must leave it in the most simplified form, what I meant was that is it possible to take out anything else common in this or to solve it or to further factorize, but I don't see any chance of factorizing it any further. So this is your final factorization. Now let us see the question number 7. Question number 7 is 15a into 2p minus 3q minus 10b into 2p minus 3q. Very simple. You can see the 2 terms here. Out of this first term, this is the second term. Out of the 2 term, already 2p minus 3q, 2p minus 3q is common. So let us take out, because it is present in both the terms. In the first term 2p minus 3q is present, as well as in the second term 2p minus 3q is present. So let us take that common, and what will be left inside? 15a minus 10b. As I said earlier also, that we must leave the answer in the most simplified form, and we must factorize till any further we cannot factorize. Now 2p minus 3q I cannot do anything because there is nothing common, but between 15a and 10b you can see there is something common. Out of 15a and 10b, a and b are different, so I can't take anything common, but out of 15 and 10 I can take out 5 common. So I'll bring the 5 here, 2p minus 3q, and when you divide it by, it will be 5 3s are 15, 5 2s are 10. Now there is no further chance of factorization. Neither I can factorize 2p minus 3q, which already in the beginning only I couldn't factorize after that, but in this term I could take out 5 common. After taking out 5 common, I'm left with 3a minus 2b, and 3a minus 2b cannot be factorized further. So let us see question number 8 now. 6 into x plus 2y to the power 3 plus 8 into x plus 2y to the power 2. Again, like in this question number 7, in question number 8 also, I have x plus 2y to the power 3, x plus 2y to the power 2. So out of these two, I can take what common? What can be taken out common out of these two? X plus 2y to the power 2. I said lower power should be always taken common. Like it is power 3, it is power 2. We must always take the lower power. So what will be left here? 6x plus 2y will be left here, and plus 8 will be left here. Now, out of these two, out of 6 and 8, I can take out 2 common. So when I take out 2 common, what will be left? 2 into x plus 2y to the power 2. And when you've taken out 2 common, it will be 3 into x plus 2y plus 4. You can open this bracket 3x plus 6y plus 4, that you can do also, and this is the complete factorization of this. Now let us go to question number 9. Question number 9 is 10a 2p plus 3q to the power 3 minus 15b into 2p plus 3q to the power 2 plus 35 into 2p plus q, 3q. It is not 3, it is q. It is q, 2p plus 3q, 2p plus q, okay? You can see it is power 2, okay? 2p plus q to the power 3, 2p plus q to the power 2, 2p plus q. So 2p plus q is common in all these 3 terms, so I will take 2p plus q as common. What will be left here? 10a into 2p plus q to the power 2 minus 15b, 2p plus q, and plus 35. Again in the second bracket I have 10, 15 and 35. In this I can see 5 can be taken out common. So I will take out the 5 common here, 2p plus q, and if I take 5 common I will be left with 2a, 2p plus q to the power 2 minus 3b, 2p plus q plus 5 7s are 35. So you have this factors, because I cannot factorize it any further. I cannot, at this stage, I cannot factorize it any further. So I will leave them as it is. So factors are clearly written here. Now let us see the last question on this bit. It is x into x square plus y square minus z square plus y minus x square minus y square plus z square minus z x square plus y square minus z square. Now it is x square plus y square minus z square in the first bracket. In the last bracket also I have x square plus y square minus z square. But in the second bracket I have minus x square minus y square plus z square. Signs are reversed. In place of plus x square it is minus x square. In place of plus y square it is minus y square. In place of minus z square it is plus z square. So what I can do is I can take minus sign common here outside that bracket. X square plus y square minus z square minus y. I've taken minus common, so it will become x square plus y square minus z square minus z into x square plus y square minus z square. Now in all the three terms, x square plus y square minus z square is here also, here also, here also. So I can take that common. That will become x square plus y square minus z square. And what will be left inside? X minus y minus z. That is your factorization. I cannot go any further because I cannot factorize x minus y minus z or x square plus y square minus z square. Okay, let's look at question number 11 of the factorization for class 9th. X square plus xy minus x minus y. We spoke to you about the factorization. Now in this we will be looking at what can we take out common. If you look at all the four terms, I can take x common out of the three terms, but I can't take out of y anything common. So sometime we have to make pairs. We have to make combinations. Like here, what I'll do is I'll combine x square plus xy into one bracket, and out of x and minus x minus y, I'll take minus 1 common and it will become x plus y. So what will happen is that out of x square and xy, the first pair, I see x as common. I will take out x common, and inside I'll get x plus y. Minus 1 into x plus y. Now you can see that this and this bracket is common in both terms. So I'll take x plus y common, and what will be left? X minus 1. So now I've got two factors of this expression, x plus y into x minus y. And if I divide this expression by x plus y, I'll get the quotient as x minus 1. There will be no remainder. And if I divide it by x minus 1, I will get the quotient as x plus y and no remainder. So that is why x plus y and x minus 1 are going to be the factors of this expression. So now we are going to do a lot of questions, about 8, 9 questions based on this, where we are going to make pairs. 5p square minus 8p cube minus 10p plus 16q. It will depend upon your practice. You're practicing as many questions you will do. You will be able to look which pair, what term should I put into one pair and what two other terms should I put on another pair. Now out of 5p and 8q, I can see, you see, out of this and this if I take out p common, I cannot take 5 and 8. But what I can pair is, like I can pair 5p square and 10p. I can make a pair of this, like 5p square minus 10p. Out of this you can see 5 is common and p is common. And let us make this another pair, minus 8p cube. Let me take minus common, so it will become plus 8p cube minus 16 cube. Because out of these two terms, I have taken minus common, so it will become plus 8p cube minus 16 cube. Why I have done that? Because 8 2s are 16, 5 2s are 10. Then q is common, q is common. Here p is common, p is common. So if I take 5p common, it will be left p minus 2. And out of this, if I take 8q common, then you will be left with what? P minus 2. So p minus 2 is common and 5p minus 8q is left. Now these are the two factors. You can see clearly that I cannot factorize it any further. I cannot factorize it any further. Now let us see question number 13. A square b minus ab square plus 3a minus 3b. Again we are going to make pairs, and making pairs will depend upon your practice. You would be able to see, as I can see it here, out of 3a and 3b I can take 3 common straight. So I will be left with a minus b. Here out of a square b and ab square, if I take ab common, I will be left with a minus b inside the bracket. And then I can take in the next step a minus b common. So I am making the pairs a square b minus ab square plus 3a minus 3b. In the first pair, I take ab common, it will be left a minus b. Out of this I take 3 common, I am left with a minus b. Because whatever you take out the common, you divide the inside terms by that. Like if I am taking 3 common, 3a divided by 3 will give you a, 3b divided by 3 will give you b. A square b divided by ab will give you a, ab square divided by ab will give you b. And then we take out a minus b common in the 2. And ab plus 3 will be left. So we have factors of this expression, a minus b into ab plus 3. I cannot see any possibility of factorization further, so we leave the answer here. Let's see question number 14. 1 minus a minus b plus ab. Again, as I said in the earlier question, earlier part of the lecture, that the pairing will depend upon your practice. You would be able to see it yourself when you start practicing. Once you start practicing, I will make this pair 1 minus a first, and I'll make minus common, take out minus common, it will be left b minus ab. Out of this there is nothing common. If there is nothing common, always 1 is common. 1 is common in everything, because if you multiply anything by 1, it doesn't make any difference. So I've taken out 1 common, and you divide 1 by 1, you get 1, you divide a by 1, you get a. Out of this you take out b common. When you take out b common, 1 minus a will be left. So you have 1 minus a and 1 minus b as the factor. And please remember, if I start the process in the reverse, that if I multiply 1 minus a into 1 minus b, I will get 1 minus a minus b plus ab. I told you in the beginning that factorization is the reverse process of multiplication. So if I multiply these two terms, these two factors actually, 1 minus a and 1 minus b, I will get the original mathematical expression. For example, let us see question number 15. X square plus xy into 1 plus y plus y cube. We told you in the beginning that we always look for common. We try to make pair, but you will say, I don't see any pairs here. If I don't see any pairs here, what should I do? I should open the bracket. I should open the bracket, multiply, and see what do I get. X squared plus xy plus xy squared plus y cubed. So I've got now 4 terms and I can make pairs, 2 and 2 pairs. So x squared plus xy is 1 pair and xy squared plus y cube is another pair. The advantage in this question was there are no negative sign, so you don't have confusion because all positive signs are there, so there is no problem in that. Out of x squared and xy, I can take out x common, x plus y. Out of xy squared and y cube, I can take y squared common, it will be left x plus y. So, in the 2 brackets, I see the common factor x plus y, and it will be left x plus y squared. As I said, these are the 2 factors of the expression x squared plus xy plus xy squared plus y cube, all to begin with here. And if I multiply this, I can get the original expression. Now let us see question number 16, which is x squared minus x into a minus a plus 2b plus 2ab. Again, I will open the bracket and then I will get 4 terms, and out of the 4 terms we will make pairs. xa 2bx plus 2ab. Here negative signs are there, but that doesn't matter. You are very well versed to handle negative sign. I'll make pair x square minus xa. Out of this minus common 2bx and minus 2ab. In the first 2 terms, x is common, x minus a. Here 2b is common and x minus a. So x minus a and x minus 2b are the required factors. Again, if I multiply these 2 factors, I will get the original expression. Thank you. Okay, let's do the 17th question, in which it is AB. In the bracket we have x squared plus y squared minus xy bracket a squared plus b squared. This is x squared plus y squared, this is a squared plus b squared. So I cannot take out common. So what I need to do is, I need to open out the brackets and make different pair. Because these pairs are already made first to first and third and fourth, and we are not getting common. That means I will avoid taking first and second. I will do first and third, second and fourth. Let us see what happens. ABX squared minus XY A squared plus ABY squared minus XY B squared. Let's see what is common in the first 2 pairs. First pair. In the first pair, I have A is common, B is not common, and X is common. Let us take AX common. If I take AX common, it will be left BX minus AY. Because X will go away from here, Y is not here, so Y will remain. Out of A square, A has gone. And out of this pair, what can I take common? I think I can take out BY common. If I take BY common, what will be left? A, Y, and minus. What will be left here? Y is gone, B is gone, so BX. Now the only thing here is, this is BX minus AY, it is AY minus BX, only the order is different, the signs are different. So what am I going to do? I'm going to change the sign by taking negative out, minus BY, and it will become BX minus AY. Now we have BX minus AY, BX minus AY, So I'll take bx minus ay and ax minus by. We get the factors which can not be further factorized. Now let us see question number 18. In 18 there are 6 terms, not 4 terms, there are 6 terms. AB square plus AB square, A square B plus AB square minus ABC minus B square C plus AX Y plus BX Y. Out of the first 2, I'll take AB common. It will remain A plus B. Out of the next 2, I'll take minus BC common. It will be A plus B. And out of these 2, I'll take XY common and A plus B is left. So, A plus B is common in all 3 terms. Here also, here also, here also. A plus B is common. And then it is AB minus BC plus XY.